Hi, so this is another update on mapping the potentiometer to servo values. Essentially, I'll be conducting a PWM, PPM, and ADC conversion process analysis. So pretty much the PPM system will be analyzing the pulse position modulation system, and then we have the PWM system, which will be analyzing the pulse width modulation system, the pulse amplitude modulation system, and finally the ADC conversion process, which is the analog to digital conversion process. So obviously, in the case of pulse amplitude modulation, the amplitude of the modulation signal with the use of carrier signals, which will act as sort of calibration point, cause the varying amplitudes in the form of digital pulses, high or low. Or in this case, you can even take Boolean values, true or false, but let's simplify it down to simply digital pulses. Alright, so obviously servos use a pulse position modulation system, or the PPM, where they use the pulse width modulation system as reference signals, as I like to call it, or in a sense positions on a plane. So in this case, the varying width of the PWM pulses are then used as reference points for the output digital pulses, as well as the carrier signals of the PPM system, which then makes its way to the microcontroller, which is on the Arduino board. Anyway, going on to the main point, during the analog to digital conversion process, what we're going to have is that there's two main factors we have to consider. Number one is the sampling rate, or in this case, we'll be sort of measuring this frequency. And number two, we'll need to consider the resolution of the system. Alright, so obviously, sampling rate, we can treat it or express it as Fs, and Fs is equal to 1 over the period, which essentially will be the amount of time it takes to complete one sampling cycle. And we'll be using the Nyquist theorem associated with this, which is pretty much a tool to help set a minimum frequency I need to avoid aliasing, which is a phenomenon when sort of the digital pulses are not sort of projected as accurately as it would be during the analog to digital conversion process. Obviously, this is extremely important because we need the servo to be as precise as possible, which includes rotating the shaft as accurately as possible, and it's part of why it's a closed feedback loop system, where we have the control circuit as well as the microcontroller receiving the position pulses from the potentiometer attached to the shaft of the motor itself. So anyway, the minimum sampling size you'll have to do is twice the maximum frequency on the input analog signal, which I'll be using in the next few processes. I hope you enjoyed the video today, which will pretty much focus on creating a more torque efficient base system, and we'll be, of course, continuing more about this PWM analysis system. Thank you.